This activity is intended to be a review in preparation for your retake on Chapter 4, Assessment 4. So next week, either Monday or Tuesday, depending on which day of Algebra 2, you will be retaking Assessments 2, 3, and 4 again. Try to improve those grades. So for the inverses, the steps are the same. Step 1 is you replace your function notation with y. So again, it could be f of x, g of x, h of x. But I can replace that with y. Step 2 is switch the variables. So generally it's x and y, but you may have y and m, for example. Third step is solve for y. And final step is return to function notation. And we're looking at this time like an inverse. So the original is the function, and then when we do the inverse, it's the inverse of f of x. So the first step is to replace f of x with y, so it becomes y is equal to 15x minus 1. Keep in mind that since the 15 is under multiplication, that means in my answer I should see division. And since the 1 is under subtraction in the original problem, my inverse I should see addition. Next step is you switch the x and the y. Step 3 is you solve. Always take care of the number being multiplied to the variable last. So the first step is add the 1. It's kind of like redoing or undoing order of operations. So if I was sticking a value for y, it would be 15 times that number minus 1. The multiplication problem is done first, subtraction is done second. So if I'm trying to solve the equation, I reverse the order so that we undo the subtraction first. And then we undo the multiplication second. So the multiplication step we would do divide by 15. So this is our inverse. So again, the last step is return back to inverse notation, and we're doing f of the negative 1. That negative 1 is not an exponent. It's read the inverse of f of x, and the answer is x plus 1 over 15. Problem number 2. Again, we're going to use the same steps. So first step is to replace f of x with y. Second step is to switch the x and the y. Third step is to solve for y. Again, we're going to take care of this piece last. So we're going to take care of the addition problem first by subtracting. So if x minus 7 is equal to 1/3 y. Now I'm going to rely on our work with exponents, and we're trying to make this value in front of the y as a 1. So anytime we have a fraction, what we've been doing is we're multiplying by its reciprocal, which will give me 3/3 when I multiply the two fractions together, and 3/3 is 1. So that gives me y is equal to. On the other side, we're going to also multiply by the same number, and 3/1 is 3. But please understand that that 3 is being multiplied not only to the x, but it's also being multiplied to the 7. So the x minus 7 has to go in parentheses. So the inverse would be 3 times in parentheses x minus 7. Now in this form, it's really easy to see the inverse because the addition problem of 7 is not subtraction. The 1/3, which actually means divide by 3, is now multiplied by 3. Sometimes you might see the answer without the parenthesis, and so if you multiply through by the 3, you would end up with 3x minus 21. And that answer is the inverse, but it doesn't look like an inverse because we're expecting that plus 7 to be a minus 7. So just be aware that sometimes in the textbooks you might find an inverse answer that doesn't look like the inverse of the numbers in the original problem, and it usually means there's a parenthesis involved. Third problem, replace f of x with y. Again, I got a multiplication problem, so I should expect division. I see a subtraction problem, I should expect addition. Next step is to reverse the x and the y, switch them. Again, we're going to undo that, take care of that multiplication problem last, so we're going to add 11 to both sides, create a 0. So x plus 11 is equal to negative 5y, and then to get the value of 1y, we're going to divide both sides by negative 5 to create a value of 1 here. So y is going to be equal to x plus 11 over negative 5. Now the negative sign can stay with the 5. I generally put the negative sign out in front. So the inverse is the opposite of x plus 11 all over 5. Now in the last problem, we're going to replace the f of x with y. Second step is to switch the x and the y. And then we're going to solve for y. In this problem, we have a parenthesis and an exponent. So if we're reversing the order of operations, the exponent would get taken care of first. Generally, we write these as square roots. So the square root of a number undoes a squaring problem. So 5 squared is 25. The square root of 25 gets me back to 5. If I do 4 squared is 16. The square root of 16 gets me back to the 4. But when I take the square root of it, the answer on the right side is going to be y minus 2, because we got rid of the exponent with the square root symbol. But on the left side, it's actually plus or minus the square root of x. Because if you think about the squaring of the parabola itself, all parabolas are U-shaped. So that means for 3, there's going to be an answer, but also negative 3 will give me the same answer if the parabola is going through 0, 0. We're expecting 2 answers because the shape of the graph is U-shaped. So there should be 2 answers for, we should get the same answer for 2 different values of x. That's the reason for the plus and the minus. Then we add 2 to both sides to get y by itself. So in doing that, we can put the 2 before the plus or minus, or the 2 after. I prefer the 2 come first, because I've found over the years that students put the 2 after the x, and all of a sudden that square root symbol gets extended too far, and it looks like the 2 is underneath the radical. So I would suggest putting the 2 in front. So the inverse for this is 2 plus or minus the square root of x. Now, the question when we did parabola before is that when we did the inverse of it, it actually looked like this. It was a U-shaped graph, but it was sideways. And so when we talked about this, we needed 2 equations, one for the top, that's the positive, and one for the bottom, that's the negative of that equation. And that's actually what's happening here with the plus and the minus. 2 plus the root x, that's the top graph, and the 2 minus root x, that's the bottom graph. This is not a function, because it requires 2 equations to actually make the inverse. 2 plus the square root of x and 2 minus the square root of x. So again, keep in mind, not all functions have inverses. And this is one of those examples. Anytime we have a parabola and we're doing an inverse, it actually ends up being 2 equations involving a square root. You might recall from algebra 1, the quadratic formula, the opposite of a number plus or minus the square root. That plus or minus is actually talking about the fact that there's 2 possible answers, and here we're talking about 2 possible graphs.